All right, geometry folks, this is 4.2, properties of parallelograms. So what you need to be able to do is use properties of parallelograms, there are 5, to identify parallelograms, and then use algebra to solve geometric problems. So you're basically using properties of parallelograms, which I said there's 5, and then you're going to use algebra with those to solve problems in geometric situations. So, parallelogram. So, what do you need to know about it? Parallelogram looks like this. Here's kind of what's true about it. You've got 2 sets of parallel sides. All right? You've also got 2 sets of congruent sides. All right? Here's kind of the other, here's 2 of them. All right? Top and bottom are parallel, left and right are parallel. Top and bottom are congruent, left and right are congruent. All right, so here's the other thing. Opposite angles are congruent. Consecutive angles are supplementary. So here's kind of what that means. Opposite angles are congruent. That means angle D is congruent to angle B. Those are considered opposite. Angle A is congruent to angle C. Those are considered opposite. Consecutive angles are supplementary. Consecutive just means kind of like the next 2. So if I said A and D would be considered consecutive. So that means angle A plus angle D has got to equal 180. Likewise, if I said A and B are consecutive. So A and B equal 180. The last piece is this. The diagonals bisect each other. So what does that mean? Well, let me clear a little space and I'll show you. So you have 2 diagonals. You have the line from A to C. You have the line from B to D. They bisect each other. So that means those 2 are cut exactly in half. Those 2 are cut exactly in half. I didn't say the diagonals are congruent to each other. I said that they bisect each other. Okay, so I'm not saying like these 2 pieces are equal to those 2 pieces. That's not what I'm saying at all. I'm just saying that the diagonals cut each other in half. All right, so kind of working backwards into an if-then statement. If the quadrilateral is a parallelogram, then the opposite legs are congruent. And if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if a quadrilateral is a parallelogram, then opposite angles are congruent. And if the pairs of opposite sides of a quadrilateral are congruent, then you can say the quadrilateral is a parallelogram. And if it's a parallelogram, then consecutive angles are going to be supplementary. So find the values of x and y so that the figure is a parallelogram. So this becomes a little bit of solving a little bit of algebra. So 6x plus 3 equals 15. I know that because it's a parallelogram. This has to be equal to this. So a little solving. X equals 2. So now when I put that in here, 4x minus 2y equals 2. So that becomes 8 minus 2y equals 2. I know that because x equals 2, so I just throw it in there. So negative 2y equals negative 6. So y is going to equal 3. So figure out these guys. Well, y plus 10 equals 2y minus 40. 4x is going to be equal to 4x up here, but that doesn't really help me. What will help me is the fact that all the angles together have to add up to 360. So what I will do is figure out what y is, and once I do that, I can figure out how big those angles are, and then I can work from there. So 2y minus 40 equals y plus 10. So that means y is going to equal 50. Subtract y, add 40, add 40. So y equals 50. So that means angle A is 60, and angle C is 60. So I've got 4x. This is also 4x because they're congruent. So 4x plus 4x plus 60 plus 60 all has to equal 360. So now 8x plus 120 equals 360. Subtract 120, subtract 120. 8x will now equal 240. So x will equal 30. So look and see what I did. I figured out that those two were 60. All four of them have to add up to 360, then it just became a matter of solving. So now, the last couple pieces here. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So I mentioned that before. These two will be congruent to each other. These two will be congruent to each other. And likewise, if it's true backwards, it's true forward. So that means negative 4x minus 2 equals negative 3x plus 4. And likewise, 3y minus 5 equals 2y plus 8. So add 4x, subtract 4, subtract 4. So I get x to be negative 6. And a little algebra down here, I get y to be 13. Okay, so that's how then it should look. So figure out the values of x, y, and z. So there's a couple different tricks we got to do here. Realize that this is a parallelogram, so still all those rules with parallel lines still come into play. But let's take this one piece at a time. 5x is across from 27. So 5x has to equal 27. So a little division gives me 5 2/5, so that's my x value. Y and y, those are the diagonal pieces. So diagonal gets bisected, so that means 2y minus 5 equals y plus 4. Y equals 9. Cool. 2/3 of the way there. Last piece is where I got to think. 3z is that angle. Realize this line is parallel to this line. This line could be considered a transversal, this diagonal. So 3z and 33 are actually alternate interior angles. So I can say 3z equals 33. So z is going to be equal to 11. So there's all three of them. All right, last piece. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So I don't say anything about this side or this side. I say one set of sides is parallel and congruent. That's enough to tell me it's a parallelogram. So take a look. Do we have enough information to tell me it's a parallelogram? Well, two opposite sides congruent? Yes. Okay. I've got one pair of opposite angles congruent, one pair of opposite sides congruent. I'm going to say no. Well, hold on one sec. Let me back up. Let me rephrase. Because what you can come up with is this. Well, hold on a second. Nope, I'm going to stand by my original answer. There's not enough information there. Here, for number 3, I've got one set of lines that are parallel and congruent. I'm going to say yes. Here, I've got one set of lines that are congruent to each other, but not necessarily parallel. I'm going to say no. Here's why. Because I could draw one here. That could also be 4. Is that a parallelogram? No, that's a trapezoid. We'll talk about that later. All right, so coordinate geometry. You need to use slope to figure this out. So slope, y minus y over x minus x. You've seen it since algebra. It needs to come back into your lives here. So if I got Q, R, S, and T, I need to figure out 4 slopes. All right, if it's a quadrilateral, 2 of the slopes should be the same, and the other 2 should be the same. So QR and ST, RS and TQ. QR and ST are the same. RS and TQ are the same. Yes, this is going to be a parallelogram. Opposite sides have the same slope, so the opposite sides are parallel. That's enough to tell me. All right, so slope is going to come into play. Down the road, distance is going to come into play. So make sure that you know both.